Hey, welcome. So, have you ever wondered about this? When gas prices shoot up, we all complain, but we still have to fill up the tank, right? But what if your favorite soda brand jacked up its price by that much? You'd probably just grab a different one, no big deal. Or think about this. Why does a 50% off sale on a brand new car cause a total stampede, but a 50% off salt sign gets, well, crickets? These aren't just random quirks of the market. There's a fundamental economic principle pulling the strings behind the scenes, and today, we're going to pull back the curtain on it. We're talking about elasticity, the secret stretchiness of pretty much every product and service out there.
All right, so here's the central mystery we're going to solve together. Let's say there's a huge bumper crop of avocados. Farmers have way more than they know what to do with. Now, in econ speak, that's a rightward shift of the supply curve. There are more avocados available at every single price. So basic supply and demand tells us the price should fall, right? But the real question is, by how much? Is the price going to totally crash, leaving farmers in the red? Or will it just dip a little bit as we all happily buy up the extra guac ingredients? The answer to that question depends entirely on us, the consumers, and how much our desire for avocados responds to that price drop. It really all boils down to that stretchiness I mentioned, or what economists call elasticity.
Okay, check this out. This slide puts our puzzle right in front of us, using two different pizza markets. Let's really break these down piece by piece. In both graphs, the vertical axis, that's the up and down one, is the price per pizza. The horizontal axis, side to side, is the number of pizzas sold per hour. Now the blue line is the demand curve, which shows how many pizzas we're willing to buy at different prices. The pink line is supply. And notice, in both pictures, the supply curve shifts out from S0 to S1. Let's say a new super-fast pizza oven was invented, making it cheaper to cook them up. So supply increases. Now look at the results. Over on the left, in graph A, we start at an equilibrium of $20 for 10 pizzas. When supply increases, the new equilibrium point shows the price absolutely cratering, all the way from $20 down to $5. That is a 75% price crash. But look at the quantity. It only nudges up from 10 to 13 pizzas. So a massive price change for a tiny little bump in sales. Now look at graph B on the right. Same increase in supply, S0 to S1. But here, the price only drops a little, from 20 to 15 bucks. But look what happens to sales. They jump from 10 all the way to 17 pizzas. So same event, two completely different worlds. The secret, the key to why this happens, is all in the shape of that blue demand curve.
So yeah, we're calling this the pizza price puzzle. And those wildly different outcomes? They're not magic. They are perfectly explained by one single, really powerful idea in economics. The key that unlocks this whole thing is having a way to measure the responsiveness of us, the consumers, to a change in price. It's all about putting a number on how much we react when a price tag changes.
And here it is. This is the hero of our story today. Price elasticity of demand. Now, it sounds super technical, I know, but the core idea is really simple. It's just a measure of how responsive our buying habits are to a change in price. I want you to think of it like a rubber band. For some products, demand is like a super stretchy rubber band. We call that elastic. You give the price a tiny little pull, and the quantity people want to buy stretches a lot. That was our pizza market on the right, the one with the flatter demand curve. For other products, though, demand is like a stiff, old rubber band. We call that inelastic. You can pull and pull and pull on the price, and the quantity people demand just barely stretches at all. That was our pizza market on the left, with that much steeper demand curve.
To really get this, let's look at the two absolute extremes. On the left, we've got something called perfectly inelastic demand. The demand curve here is a straight, vertical line. Its elasticity value is 0. What this means is that no matter what happens to the price, if it's $6, $12, $1 million, the quantity people demand stays exactly the same. The classic textbook example is a life-saving drug like insulin for a diabetic. They need a certain amount to live, a lower price isn't going to make them buy extra, and a higher price can't make them buy less, because it's a total necessity with 0 substitutes. Now on the right is the complete opposite, perfectly elastic demand. Here the demand curve is a perfectly horizontal line, and its elasticity is infinity. In this world, consumers are infinitely sensitive to price. If the price is exactly $12, they'll buy any amount you can produce. But if a seller tries to charge even a penny more, say $12.01, demand instantly drops to 0. Nobody buys. This happens in markets where there are perfect substitutes, like say wheat from one single farm. If every other farm is selling wheat for $12 a bushel and one farmer tries to charge more, why would anyone buy from them? They'll just go to the next farm.
Okay, so we've got this concept of stretchiness, elastic, inelastic, but how do we actually put a number on it? How do we measure if a product is more like that life-saving insulin or more like that farmer's wheat? That's what we're going to dig into right now. And it's not just about the math, it's about getting to the why behind how we all behave as consumers.
So, this is the formula, and I promise it's way simpler than it looks. All it says is that elasticity equals the percentage change in quantity demanded divided by the percentage change in price. It's really just a ratio. We're comparing the size of the reaction, the change in quantity, to the size of the thing that caused it, the change in price. Let's go back to our first pizza example, the one with the steep curve. The price fell from $20 to $5. That's a huge 75% drop. But the quantity sold only went from 10 to 13, which is a 30% increase. So you just plug it in. 30% divided by 75%, that gives you 0.4. The formula just showed us that the price change was way bigger than the quantity reaction. Oh, and a quick technical note. Since price and quantity always move in opposite directions, this number will technically always be negative. But economists are really just interested in the size of the response, the magnitude, so we basically just ignore the minus sign and look at the absolute value.
So we calculate a number. What does it actually tell us? This slide lays it all perfectly for you. If the number you get is bigger than 1, it means the top number in our fraction was bigger. The percentage change in quantity was greater than the percentage change in price. We call this elastic demand. People are super responsive. If the elasticity is less than 1, like that 0.4 we just calculated, it means the bottom number was bigger. The price changed by a lot more than the quantity did. We call that inelastic demand. And if by some chance the number is exactly 1, it means the percentage changes were perfectly equal. And that, you guessed it, is called unit elastic. Now this is a super important point, and it's something that trips up a lot of students, so listen close. Elasticity is not the same thing as the slope of the demand curve. Look at this graph. It's a single straight line, which means its slope is constant, it never changes. But its elasticity is changing all over the place as we move along it. Let's start way up at the top. When the price is high, say $25, demand is elastic. The elasticity value here is 4. Why? Well, think about it. A price cut from $25 to $20 is a 20% drop. But the quantity people buy jumps from 10 pizzas to 20. That's a 100% increase. So a relatively small percentage price cut leads to a massive percentage quantity increase. That's the definition of elastic. Now follow the line down to the middle. At a price of $12.50, elasticity is exactly 1. It's unit elastic. But look what happens when we get down to the bottom where prices are low. Demand becomes inelastic. The elasticity here is just a quarter or 0.25. Why? Because a price cut from $10 to $5 is a huge 50% price drop, but it only increases sales from 40 to 50 pizzas, which is just a 25% increase in sales. A huge price cut gets a pretty small reaction. So the big takeaway here is that a single product can be both elastic and inelastic. It just depends on what the current price is.
All right, so we can calculate this number, but so what? Why does this actually matter in the real world? Well, this next part shows you how elasticity isn't just some abstract theory, it's an incredibly practical tool. If you're running a business, probably the biggest question you ask yourself is, if I mess with my price, am I going to make more money or less money? Elasticity is how you find the answer. This is called the total revenue test, and it is absolutely essential for any pricing strategy.
This quote from our source material really gets to the heart of the matter. It kind of feels wrong, doesn't it? I mean, you'd think charging more always means more money in the bank, but it all comes down to how your customers respond. It all depends on the elasticity of demand. And sometimes raising your price can actually make your total revenue go down.
And this slide, this is the aha moment. This brilliantly shows you why. On the left, you see our pizza demand curve again. On the right, you see what's happening to total revenue, which is simply price times quantity as we move along that curve. Let's trace it. Start at the top left in the elastic zone. Let's say the price is $25. You sell 10 pizzas. Your revenue is $250. Now, let's say you cut the price to 20. You sell 20 pizzas. Your total revenue is now 20 times 20, $400. Now look at the revenue curve on the right. It's going up. Because demand is elastic here, the massive increase in the number of pizzas you sell more than makes up for the lower price you're getting for each one. And as you keep cutting the price, revenue keeps rising until you hit the exact middle of the demand curve where elasticity is 1. At that point, a price of $12.50 selling 25 pizzas, you hit your maximum possible revenue, $312.50. Now watch what happens if you keep cutting the price into the inelastic zone. If you cut the price from $10 down to $5, your total revenue actually starts to fall. At $10, you sell 40 pizzas for $400 in revenue. But at $5, you sell 50 pizzas for only $250 in revenue.
Your revenue curve is now heading downhill. Why? Because down here in the inelastic region, the few extra sales you get are just not enough to compensate for that big drop in price. This relationship is like the golden rule for any business owner.
So let's just hammer this home. This is the crucial takeaway from that total revenue test. If your product's demand is elastic, meaning your customers are super price sensitive, a price cut is a great move. It will increase your total revenue. On the flip side, raising your price would be a terrible idea. You lose way too many customers. But if your product's demand is inelastic, meaning people are going to buy it no matter what, then a price cut is a bad idea. It'll actually decrease your total revenue. In that situation, you would make more total money by raising your price because you won't lose enough customers to cancel out the higher price you're charging. Understanding this is absolutely fundamental to making smart business decisions.
So far, we've really just focused on how customers react to price changes. But this whole concept of elasticity, it's like a Swiss Army knife. It's a powerful toolkit that can be applied to so much more. It's a way of thinking about responsiveness that you'll see everywhere in economics.
So what actually determines if a product's demand is stretchy or stiff in the first place? Well, here are 4 of the biggest factors. First, the availability of substitutes. The more choices you have, the more elastic the demand. If Coke raises its price, you can easily just buy Pepsi, so demand for Coke is pretty elastic. But if the price of all soda goes up, there aren't as many direct substitutes for the whole category, so demand for soda is more inelastic. Second, is it a luxury or a necessity? Demand for luxuries, like a fancy sports car, is elastic. If the price goes up, you can easily live without it. But demand for necessities, like your prescription medicine, is inelastic. You need it, period. Third, how much of your income does it take? Demand for big-ticket items, like a house, is more elastic. A 10% price change is a ton of money, so it hugely impacts your decision. But for something cheap, like a pack of gum, a 10% price change is just a few pennies. You won't even notice. Demand is very inelastic. And finally, time. The more time that passes after a price change, the more elastic your demand becomes. When gas prices first spike, you still have to drive to work tomorrow, so your demand is inelastic. But give it a year, you might buy a more fuel-efficient car, start carpooling, or move closer to your job. Over time, your demand becomes much more elastic.
And here's a quick look at the rest of that toolkit, which just applies the same responsiveness logic to other relationships. First up, we have cross-price elasticity. This measures how demand for good A reacts when the price of good B changes. For example, if the price of movie tickets goes down, what happens to the demand for popcorn? It goes up. They go together, so they're complements, and their cross-price elasticity is a negative number. But if the price of coffee goes up, what happens to the demand for tea? It also goes up because people switch. They're substitutes, so their cross-price elasticity is a positive number. Then there's income elasticity. This measures how your demand for something changes when your income changes. If you get a raise and start buying more fancy dinners, those are normal goods. They have a positive income elasticity. But if you get that raise and buy way less cheap instant ramen, then instant ramen is an inferior good for you. It has a negative income elasticity. And finally, we can flip the whole thing around and look at elasticity of supply. This isn't about us as consumers, it's about the producers. It measures how responsive they are to a price change. If the price of cotton t-shirts goes up, can a factory easily ramp up production? Yeah, probably. So the supply is elastic. But if the price of a Picasso painting goes up, can we produce more of them? Nope. The supply is perfectly inelastic. So there you have it, the secret stretchiness of markets, all laid out. We started with that pizza price puzzle, we learned how to measure and calculate elasticity, and we saw how that incredibly important total revenue test can help a business figure out its pricing. It's this amazing toolkit for understanding responsiveness just about everywhere in the economy. So I'll leave you with a question to chew on. Thinking about your own life, your own spending, what's one product you buy where your demand is super elastic? Where a small sale or a price hike totally changes your decision. And on the flip side, what's one thing you buy that's totally inelastic? Thanks for joining us.